Okay, business calculus students, hello. In this video, I'm going to work on 4 problems that one of the students in the class emailed me about. Um, excuse me. He told me that he was having problems with questions 36, 37, 48, and 50. So this video is about those 4 questions in your homework. Question 36, question 37, question 48, and question 50. Hold on one second. Let me pause the video for just a moment. Okay, so here we go. Here's Mathematica. Okay, so let's take a look at problem 36. Problem 36 reads, find each indicated quantity if it exists. Let f of x be defined as a piecewise function. For x is less than -3, the definition is x plus 7. For x is greater than -3, the definition is the square root of x plus 3. Complete parts A through D. Part A, select the correct choice below, and if necessary, fill in the answer box to complete your choice. Okay. Let me move this over a little bit. First of all, you really need to learn how to graph these problems. Now, granted, if you study calculus for a very long time, if you get into advanced calculus, you're going to encounter problems that are really difficult to solve graphically or visually. However, this is not an advanced calculus course. This is a basic calculus course. It's a basic calculus course intended for business majors and people majoring in the social sciences. So a lot of the problems in this course actually can be analyzed graphically. So what I strongly recommend is that you learn to graph these problems. You could graph them using a graphing calculator. Obviously that is not my preference. My preference is to use the Mathematica software. Okay. If you have not downloaded and installed the software, then I strongly recommend that you do so as soon as possible, because I think it's going to really help you in this course as well as future math courses, statistics courses, finance courses, even your computer science courses. It's pretty good software, and it's versatile, and it can help you with a lot of different courses, okay? Not just this course, but other courses as well. So let's get started, okay? First of all, I'm going to define a function here. I'm going to call it function f. My argument is x, and remember that the argument to a function, okay, you can give it any letter you want. I'm going to use x because that's the letter that represents the argument in this problem, but you must always follow that with an underscore. The underscore tells Mathematica that x is the input or the argument to the function f. Okay? It's a piecewise function, and it's defined as x plus 7 when x is less than -3. The square root, control 2 gives me the square root. Okay? Once again, guys, control 2 gives me the square root symbol. X plus 3 when x is greater than -3, and otherwise our function is undefined. Shift Enter. Okay, terrific. Plot f of x. Now it looks to me like, according to the problem, we're interested in what's happening when x is equal to -3. So that means I want -3 to be exactly in the middle of the graph. So if you want -3 to be exactly in the middle of the graph, that means you want an equal number of steps to the left of x is equal to -3 and an equal number of steps to the right of x is equal to -3. So, excuse me, so x is my argument, x is my so-called variable or the argument of the function f. I'm going to go, let's see, -3 plus 4 is going to be 1. That'll be my maximum. And then -3 minus 4 is -7. So therefore, my graph window will show everything that's happening from x is -7 to x is +1, and -3 should be exactly in the middle. Okay? And the picture looks like that. Not a bad picture. We can make the picture even better. We can do something like this. We could say ticks. The vertical ticks look okay. The horizontal ticks could look a little bit better. Table. I like the letter K. K goes from -7 to 1. Okay, and I need to use list braces. And I'm going to let Mathematica pick the ticks on the vertical axis. The vertical axis comes second. Okay, so now I can see, and by the way, you should remember this from the last video, table K, table K goes from -7 to 1. This is what it does. Table K goes from -7 to +1, gives me a list of all the integers from -7 to +1. -7, -6, -5, -4, -3, -2, -1, 0, and 1. That's what this command does. Okay? So I hope we're okay with that. And we could make the picture look even nicer. Tick style. This is a directive. Font color can be black, and font weight can be bold, and font size 14 pixels, and font family, I happen to like Arial. Okay, now it's starting to look even better, and we could also add a little artistic style to these curves. We could say plot style can be thick, and how about blue? We could a little thicker. Absolute thickness 5. Okay, terrific. That looks like a really nice picture, one that we can, one that we can really analyze, okay? Now, this is the point. This is really, really important. Let's look at the problem now. This problem says, what is the limit as x goes to -3 superscripted plus? That's my dog. Sorry about it. Okay, so what is the limit as x goes to negative 3 from the right side? Chachki, stop! Oh. What is the limit as x goes to negative 3 from the right side? That's what the plus means, from the right side. So we're only looking at this half of the function. We're only looking at this, follow my cursor, we're only looking at this half of the function. Okay, so the answer is going to be the square root of x plus 3 when x is equal to 0. I'm sorry, when x is equal to negative 3. The square root of x plus 3 when x is equal to negative 3. What is that? Well, that's pretty obvious. It's going to be 0, right? So we have the square root, or you could do control 2, x plus 3, right? What happens when x is negative 3? Well, of course, it's 0 because negative 3 plus 3 is 0 and the square root of 0 is 0. So that means the answer is going to be 0. Okay. Let's see. Select the correct choice below and if necessary, fill in the answer box to complete your choice. What is the limit as x goes to negative 3 from the left side of f of x? Well, we're going to have to look at the function definition to the left of x is equal to negative 3. And that's going to be x plus 7. What is negative 3 plus 7? That's the same as 7 minus 3. That's going to be 4, right? So if I have x plus 7, when x is negative 3, the answer is 4. The answer is 4. Okay, select the correct choice. Okay, this is the same old, same old. Now, what is the limit as x goes to negative 3 from both sides? This is the bidirectional limit. Okay? The left-sided limit is 4. The right-sided limit, or the limit from the right, is 0. The limit from the left is 4. The limit from the right is 0. 7 is not equal to 0. When the two limits, when the left-sided limit and the right-sided limit do not agree, then the bidirectional limit does not exist. And that is correct. Okay, so here, well, you can see from the function definition, f of negative 3 is undefined. F of negative 3 is undefined. So we can see that here. What is f of negative 3? It's undefined. And if there is no limit at f of negative 3, that means the function is not defined at x is equal to negative 3. So we know that that's correct. Okay. So let's look at problem 37. Problem 37 is very, very similar. You just have to try to remember to do some algebraic factoring. So right over here, what is x squared minus 16 divided by x plus 4? Okay, well, we know factor x squared minus 16. Let me make that look a little bit more traditional. Traditional form. Okay, x minus 4 times x plus 4 is the same as x squared minus 16. If I divide by x plus 4, that means I'm left with x minus 4. So that means that when x is less than 0, f of x is going to be equal to x minus 4. Okay? Here, when x is greater than 0, right, I have x minus 4 times x plus 4 in the numerator. And if I divide by x minus 4, I'm left with x plus 4. So when x is greater than 0, I have x plus 4. Okay? So again, let's define this function. So clear f of x is equal to a piecewise function. So we have x minus 4 when x is less than 0, and then we have x plus 4 when x is greater than 0. Otherwise, the function is undefined. Okay? So we're interested, let me see, what is the limit as x goes to negative 4, 0, 4? Okay. So here, when x goes to negative 4, okay, that's really simple. We know that the function is defined at x is equal to negative 4. F of negative 4 is simply equal to negative 8. All right, so the function, there is going to be a break in this function when x is equal to 0. And I'll show you that in a moment. When x is equal to 0, there's going to be a break. All right, but there is no break when x is equal, it's called a discontinuity or a break. There is no break or discontinuity when x is equal to negative 4 or x is equal to positive 4. There is, however, a break or a discontinuity when x is equal to 0. So here, we're just going to type negative 8. That's the answer. That's it. Okay. What is the limit when x goes to 0? Now, there we have a problem, and I'm going to show you why. Okay, so plot f of x, and let's go 10 steps to the left of 0 and 10 steps to the right of 0. Okay, so this is a break. This break is called a discontinuity. And because of this, we know that the bidirectional limit does not exist. So the limit when x goes to 0 here, oh, sorry, actually this is option B. The limit does not exist. The limit does not exist because of the break or the discontinuity that you see in the graph. Okay? When x goes to 4, well, that's simple. That's just going to be x plus 4, so 4 plus 4, that's going to give you 8. And that's pretty simple. So, yeah, I mean, these problems really are not that bad. You have to visualize them, okay? You have to graph them, you have to visualize them. And if you visualize them, you're going to realize that these problems are really not that big a deal, okay? So let's take a look now at problem 48. Problem 48. Okay. So problem 48, let me move this over a little bit. Okay, find the limit as h goes to 0, f of 6 plus h minus f of 6 divided by h, if f of x is equal to 5x minus 9. Okay, so let's do this. I'm going to clear f, and we're going to redefine f in Mathematica, okay? F of x is equal to 5 times x. You could write 5 times x, or you could just do space x. 5 times x minus 9. Okay? And the limit, how should I write this? I'm going to write this as a function of h. The limit of h is equal to f of 6 plus h minus f of 6. The whole thing, okay, highlight the whole thing, control divide by. divide by h. Shift enter. Limit h expand. Okay, so here, if you do an algebraic expansion of this function, you're going to be left with the number 5. Let me show you why. Let me show you why that is. Hold on one second. Okay. There we go. So if I do an algebraic expression of the limit, I know that I'm going to end up with a constant 5. So let's see, why is that? Here, hold on one second. So there we go. Okay. I'm going to try to use this drawing tool, but this isn't real easy, but I'll give it a shot. 6 plus h, just bear with me, be patient, guys. There we go. Minus f of 6 divided by h is equal to, now what is f? So I'm going to have 5 times 6 plus h, 6 plus h, minus, let me see, minus 5. Oh, you know what? Wait. Hold on. I'm not writing this correctly. Sorry, let's start this over. Whoa. Let's start over. Okay. We have f of 6 plus h minus f of 6, okay, divided by h. So that's going to be 5 times 6 plus h minus 9 minus f of 6, so we have 5 times 6 minus 9, and the whole thing divided by h. Okay, I'm running out of space here, but let's see. So this is going to be 5 times 6 is 30. 30 plus 5h minus 9 minus 5 times 6 is 30. Well, 30, okay, so 5 times 6, we know that's going to be 30, and 30 minus 9 is 21. So this will be minus a 21. Okay, the whole thing divided by h. And then we're going to simplify this. So we're going to have, let me see here. Hold on one second. So we're going to have 30. Hold on one second here. So we're going to have 30 minus 9, which is 21. Oh yeah, I see what's happening. Okay, so let's draw the arrow over here. We have 30 minus 9 minus 21. Okay, 30 minus 9 is 21, and 21 minus 21 is 0. So you're left with 5h divided by h, and we can see that the h's cancel. You're actually going to be left with 5. Okay? 5 is correct. That is the answer. 5 is the limit. 5 is the limit. Control X. Let me see. Let me get rid of all this scribble. So the answer is simply going to be 5. Okay. Let's take a look at number 50. Let's take a look at number 50. Let's see. Okay, so here, the same idea, guys. So find the limit as h goes to 0 as f of 1 plus h minus f of 1 divided by h if f of x is equal to the absolute value of 5x minus 1. So let's give this a shot. Okay. Those absolute value functions can be a little bit weird. They can definitely be a little bit weird, but let's give it a shot. So clear the definition of f. F of x, oops, f of x is equal to the absolute value of 5 times x minus 1. And the limit as a function of h is equal to f of 1 plus h minus f of 1, and the whole thing divided by, control divide by, h. Shift enter, okay. What is the limit as h goes to 0? Okay, so we're getting indeterminate, so we're getting, because you can't divide by 0. Okay, you're not allowed to divide by 0. So I'm curious, what is the limit of h, as h goes to 0? Again, the answer is 5. Again, the answer is 5. So here I'm cheating a little bit. Okay. Mathematica has a built-in function that finds most, but not all limits. Okay? Mathematica has a built-in function that finds most, but not all limits. It's simply called the limit command or the limit function. Okay? So limit of h as h goes to 0, and the answer is 5. Okay, so again, guys, I'm going to, I could write this out for you using that, drawing tool, but I'm going to let you try to figure that out for yourselves. I mean, you can, of course, you can use Mathematica to find the answer. If you would rather find the answer by hand, that's okay too. But in this case, I don't want to do it for you. I want you to sweat a little bit and try to figure it out yourselves. Okay? So if you're really lost and you cannot find the limits, you can always use Mathematica's built-in limit command, just like I'm using it right here. And if some people are confused, like, how did I get this magic arrow? The arrow is really easy. The minus key, shift period, right? Shift period gives me the greater than symbol, and then space. It's really easy. So if you're really confused and you're not sure how to find a certain limit, okay, you can use the built-in limit command. If you want to try this by hand, excuse me. If you want to try to find the limit by hand, that's fantastic. Go for it. But in this particular case, I'm not going to do it for you because I want you to do some of the work. I want you to sweat a little bit. I think it's good for teachers to sometimes show you the right direction to go in, but I don't want to hold your hand and, do every single problem for you. I want you to sweat a little bit and do a lot of the work by yourselves because that's really how you learn the material. You learn the material by actually doing it. Not just by watching someone else do it, but by actually doing it yourself. Okay? All right, guys. But actually, your approach, if you want to find the limit manually, your approach is going to be very similar to what I did right over here. I erased all the red scribble, okay, because it was very distracting. But your approach would really be very similar. Okay, I think that's enough, and hopefully this video will help you. And in case it doesn't help you, let's say it doesn't help you. Let's say that you watch this video and you find it very confusing. You have options. Help me solve this. View an example. Watch the accompanying video. Not my video, but a different video. Open up your textbook. Read the textbook for the course. And if you're really, really stuck and can't find the answer, you can email me. Click on Ask My Instructor. Or you can print out this problem, print it out, and show it to someone in your family or a neighbor or someone that you know who is really good at mathematics. Guys, you have options. You have choices. You need to learn to take advantage of your choices, take advantage of your options. You have a lot of options to help you with this course. Okay? Learn to take advantage of them. All right, guys, I think we are done. That's enough of a lecture for today. I hope you're healthy, stay well, and please study hard and read your textbook. That's it for now. Bye-bye.